So one of the first things we're going to start with here, so we are told that limits of linear functions, right? So we're talking about when x, the highest power, is a 1. It says the limit as x approaches a of f of x is equal to f of a. So what that's telling us here is when we're dealing with linear functions, that we can take this value here, the whatever x approaches, whatever that a is, and we can do a direct substitution and plug that in. So for example, this first example that we have here, the limit as x approaches x of 1/2 x minus a 7. So according to this law, it is telling us that we can take this 3 and just plug it in for x. So that'll be 1/2 times 3 minus a 7. Now that's going to give us 3/2 minus a 7. And when we calculate that, get common denominators and all of that, 7 over 1, we'd need to multiply that by 2 over 2. So that's really going to be 3 minus a 14 here. And we are going to be left with a negative 11/2 for that limit. For this next example, same thing. It is asking us to find the limit as x approaches 2 of g of x, where g of x is equal to 6. So what I'm going to do is I'm going to rewrite this. They're asking us to find the limit as x approaches 2 of g of x, but they're telling us that g of x is equal to 6. All right, so we're just going to take that 6 and plug it in here. Now, because our function does not have a variable, there's nowhere for us to plug this 2 actually in. What that means is that this function is always going to equal 6, right? G of x is 6. So the limit at any value, this is always going to equal 6 because it's a 6, right? That's all we got here. It will always be a 6. So this limit is a 6.